Hello everyone, my name is Jiman from Yonsei University, Department of Prosthodontics. It's my pleasure to make do a lesson with you about the evaluation and application of digital dental equipment. The contents of our lesson will be like this. At first, I will show you the digital workflow, and then you can understand what is digital workflow and how can we utilize that technology to our daily clinic. Then I will talk about a history and evaluation of intraoral scanners. Intraoral scanner is a image acquisition device, and it is the opening gate of digital workflow. Lesson 4 will be evaluation items of image acquisition equipment. I have been conducted many researches on intraoral scanners, so I can provide you many good techniques to evaluate those devices. Lesson 5 will be status of digital dentistry division in ISO. There is Korea dentistry division in International Organization for Standards. So I will introduce how the specialists gather together and make some standard about the digital devices. Lesson 6 will be integration of multi-source data and clinical acquisition. There are many devices such as intraoral scanner, facial scanner, CBCT, and after we align those data in the exact location, we can utilize those data very effectively. We call that as virtual patient. Lesson 7 will be interoperability of CAD softwares. There are many dental CAD softwares, but after we save the project data on CAD software, we cannot load on another software, and the ISO specialists are doing jobs on the interoperability, and after that standards are finished, we can freely operate those project data on various dental CAD softwares. Lesson 8 will be how to use 3D measurement software for evaluation. I will show you how to evaluate the data acquired from many devices. Lesson 9 will be milling machine performance evaluation items, and lesson 10 will be method for evaluating chairside milling blocks. From lesson 9 and 10, you can understand about milling machine and the resultant material will be helpful for our digital workflow. Lesson 11 will be performance and safety evaluation of 3D printing systems, and lesson 12 is current status of metal and ceramic 3D printing technology. From lesson 11 and 12, we can review all about the 3D printers and its relative materials. Lastly, from lesson 13, I can show you the importance of CAD/CAM equipment calibration. When you are operating a milling machine or 3D printers, we have to do a exact calibration before we are using those devices, because resultant devices should fit well on the patient's mouth. And lesson 14 would be digital dental manufacture and its clinical application. As we are utilizing milling machine and 3D printers, we can apply those technologies to manufacture dentures. So it would be very interesting, and the opportunity to review all the lessons we have done with these digital denture manufacture themes. Yes, now let's start with introduction section. Please look at the news. They are published in Korea. See, digital dentistry evangelist. I really enjoy using an intraoral scanners and various CAD software in my clinic. And also I have been working with many dentists in different fields to help them to get the hang of it easily in their clinic. Digital dentistry evangelist is my another name. One more thing that I want to tell you is that I have used and tried many intraoral scanners, as you can see on the slide. I have been using intraoral scanners to treat patients in my clinic almost like over 10%, 70% for over 10 years. And as a team, our group have published so many researches on that. Back in 20 years ago, when I was a student in dental school, I was always interested in electronic gadget and digital hardware. How look I am? Digital era has come to me. So after being a prosthodontist, even during prosthodontics residency, I was seeking for a better solution with digitals. I've got so many opportunities to give lectures with titles such as accuracy and clinical effectivity of intraoral scanner, dental application of 3D printers, and integration of intraoral and facial scans. There are various digital devices around me, but there are much more people who help me. My friends from very many universities are also very grateful to help me. As a digital dentistry evangelist, I have lectured on clinical applications of digital technology in many international lectures, including Osteology Foundation World Symposium. I'm working as a secretary at the working group for 3D printed dental device of ISO, International Standard Organization. At Yonsei University Dental Hospital, I'm a director of Digital Aesthetic Clinic. I am working on replacing most of the routine dental treatment with digital technology. I'm accumulating evidence in this practice through research. I'm also trying to communicate these results and spread digital dentistry through various lectures. My colleague, professors, and I spend a lot of time to let the undergraduate students experience digital dentistry. I have gained a great response from several courses, such as how to acquire excellent intraoral scan and practicing dental CAD software for various clinical applications, such as crown design, facial scan to create accessory of my own face. After you scan your own face, you can operate the data file and make a accessory such as keyring. And understanding 3D printers understanding 3D printers and operate by myself. Every summer and winter break, a digital dentistry workshop is conducted for undergraduate students. Depending on the level, training is provided in basic and advanced courses. My colleague professors and I renovated student prosthetic laboratory in the building into a digital training space. From last semester, digital education is being done in a regular curriculum rather than an extracurricular classes. Two years ago, two dentists from Kyrgyzstan came to learn digital dentistry. I gave them the opportunity to learn digital in a one-week course, and they observed the lessons like a sponge. They are establishing digital workflow in their country now. We get in touch even after they returned home. If someone who is concerned with this curriculum, please contact me. I also went to Kuala Lumpur. I gave a lecture at a symposium hosted by the Malaysia Implant Society and one-day digital workshop the next day. The participants had time to design a lot of what I'm going to talk about on these lessons. All the attendants were very focused and I was very impressed. So from the lessons of my class, you can learn very basics and advanced themes. So I will show you brief content from this lesson. The second lesson 2 will be understanding digital workflow. CAD/CAM, the term of CAD/CAM is divided into CAD and CAM. In the dentistry, CAD includes also digital data acquisition, such as intraoral scan or model scan. And with dental CAD software, we can design restorations or appliance on the data that we acquired with various devices. In the CAM aspect, you have to understand what is toolpath calculation and or support generation. We have to use CAM software to operate milling machine or 3D printers. After that, we can get a restoration that we can use in a daily clinic. Let's see the workflow of our clinic. When we are making a crown restoration, we usually make an impression with silicone material, and we pour stone or plaster to make model. We do a die preparation. On that die, we wax up the crown and cast it into metal. After that, we build a porcelain and try the restoration in the clinics, in the patient's mouth. But when we utilize digital dentistry, the workflow will be changed. After tooth preparation, instead of making impression, we acquire a digital impression. We acquire digital image. from various devices. And instead of model fabrication and die preparation, we make a virtual model. And on the CAD software, we do design what we have done with a workshop procedure. After that, instead of testing technique, we do CAM procedure with milling machine. So if you are if you get accustomed to digital workflow, you can do things like this. We make a digital impression before tooth preparation and after the tooth preparation. After you finish it, abutment preparation, you only have to erase the abutment tooth area and scan that area. After that, the computer software automatically calculate and subtract the abutment tooth data and complete a restoration design. When we use intraoral scanner, we do not get a physical model, so we have to print out the data into model with 3D printer. So we have to design dental model with model building software. After that, we can print out all those data into restorations, provisional restorations, and models. And I will introduce the various technologies to complete the restorations. At first, I will show you how to merge conventional technology and digital technology together. So I will show you how to scan the models mounted on semi-adjustable articulator. We can scan articulator itself and transfer all those shapes into CAD space. Then we can design the patient's restoration in the virtual space. After that, we can build out a PMMA, provisional restoration, trying in the patient's mouth and copy into final restoration. We call it as digital, which is digital plus analog technologies. At the lesson 3, the history and evolution of intraoral scanners, I can explain all about the intraoral scanners. A lot of intraoral scanners are introduced, and there are many things to consider before we can apply in the real clinical situation. So, because the price of the device is very expensive, we have to get the various kinds of details regarding this device before we can invest in it. So I can show you all the factors considerations about intraoral scanners. So that will be accuracy, clinical efficacy, and hardware itself. So with this lesson, you can understand all the details of intraoral scanners. And because you have to utilize intraoral scanners in the real clinical setting, the accuracy of intraoral scanner is very important. The first thing to consider, so I will introduce you various research results which I have done until now. As you can see on the slide, the same abutment tooth can express various shapes depending on intraoral scanners. They also have defects shown at this photo. So we also have to inspect the resultant acquired data before we submit transfer into the other laboratory or design center. And because intraoral, the optical window of intraoral scanner is tiny, the resultant complete arch data can distort. So I will show you how to evaluate the degree of distortion by explaining my research result on the complete arch distortion from intraoral scan data. With intraoral scanner, on the lesson 4, evaluation items of image acquisition equipment, we always make restorations modellessly with intraoral scanner. So many clinicians can give a question, erase a question about the accuracy of modellessly fabricated crowns. So I will show you what is different from the conventional made crown. As you can see, digitally made, modellessly produced crown can be over-controlled. So I can explain you why this over-controlled restoration can be resulted, and you can understand all about the modellessly produced crowns characteristics and how to escape from this result. Also, regarding the efficacy, I will explain about the hardware and software of intraoral scanners. And regarding the scan time, we have to think about a learning curve, because these intraoral scanners are digital device and we have to learn how to operate effectively. So I did some research on learning curve and the progress of accuracy, so you can understand about the learning curve and about intraoral scanners. And I also will explain about desktop scanner, and we can get some advantage when we are using the, desktop model scanner when we are dealing with subgingival margin cases. Recently, many manufacturers are introducing to get some digital data, model data from convimsity. So I will explain about the trend which is done by a radiographic devices. And when we are considering the model scanner, desktop scanner, there is a ISO standard on the accuracy of these devices. So I can explain about this. Okay. On lesson 5, status of digital dentistry division in ISO. I am participating at the international meeting every year, and I am working on making a standards about 3D printers in dental subcommittee. So I will explain what is going is made in this ISO community. So in the 3D printing working group, I'm working as a secretary, so I can explain more in detail about the standards, how the standards are made and revised and published. And on the lesson 6, integration of multi-source data and clinical application, I can show you how we can combine all those data to design and manufacture restorations such as crowns and dentures. We can utilize intraoral scan data to fabricate individual tray and print it out and make a denture impression. On this lesson, I will show you how to utilize the bite jig which I designed and manufactured for this purpose. After we finish this lesson, you can you can easily get a facial scan data and combine intraoral scan data with it. So in this technology, the alignment is very important, and I can show you how we can exactly accurately align multi-source data into a virtual patient. After then, we can use this virtual patient when we are making crowns, dentures, and various appliances such as surgical guides. I am making I also will show you how to make a virtual patient from the patient, a real patient, and utilize it into evaluating and planning the treatment and preparing for the provisional restoration. From this lesson, I can show you the facial scan, utilizing facial scan data and mandibular tracking data, so we can get some information from the real patient's mandible motion. From lesson 7, interoperability of CAD softwares, I will show you various aspects about the interoperability aspect. So we are using various dental CAD softwares from many manufacturers, and it would be very helpful each characteristics of dental CAD softwares. Lastly, on this lesson, chairside CAD softwares will be changed into three directions, and we will easily use those softwares. So I will introduce about these three directions. First one is simple CAD. Second one is web-based CAD, and the last one is on-demand services. So from this lesson, we can learn how to utilize the data easily with various CAD softwares from many companies. Beside those introductions, there are many aspects about manufactured devices such as milling machine and 3D printers. So from our courses, I will introduce how to utilize digital devices effectively. So let's continue to learn about these aspects. Thank you very much.